Daniel, and welcome to What's New in Swift. They asked to talk about some of the things that are new in Swift, and you'll see the things that I care about because we'll spend more time on those. Of course, there's the really big things that we've seen in the last year, like ABI stability, which doesn't mean so much to us day to day, but if you have time to read what went into it, it's kind of cool. It's the memory layout and the interaction with C and all the things that kind of needed to happen. And then, of course, this year we got the module stability. But let's start with some little things, and this is one of my favorite little things. We have a little function here that takes an int and returns an int, and we return 2 times the input, and one of the nicest things in Swift 5.1 is return is gone. And it's going to look strange to you. It's going to look strange to you, but think about the Swift you write now. None of you use a semicolon at the end of the line, and that kind of looks strange too in the beginning too. Now, the thing that's odd, though, is it's only for single expressions, and so if you put a print statement here, this breaks the code. It doesn't compile. If I have an if is a statement, not an expression, and so I actually can't do this here either because it's for single expression functions, and so I need a return here and here. And so in those cases where you can, it's kind of nice to use, especially in places like this, custom string, convertible, where you've got a computed property. That's essentially the same as a function, and so you can get rid of your return there, and that reads cleaner. Little things that came up on us, and then we'll get to the SwiftUI and other stuff like that. Raw strings, I don't know if any of you use raw strings, but if you write something like this, I say happy birthday to whatever age you are, this prints this out, but what if you wanted to put quotes around the happy birthday? So what if you wanted to say happy birthday in quotes? Well, this wouldn't compile, of course, because that would delimit strings like that. The happy birthday is kind of in the middle. So what they gave us in SE200 is this new annotation before this pound sign, and so now you can put quotes before the happy birthday and it's not confused because those are different quotes, and this now puts the quotes around that, but the slashes are printed because those are literals, and we can fix the slashes by saying, well, we've got our pounds there, let's just go ahead and pound escape those as well. And so when we pound escape the slashes, then we get the thing that we want. And so these are the raw strings. And this works with multi-line. I don't know if any of you use multi-line strings, but it's the same thing there. And notice that I've pound slashed the end of the line as well. And so now you see something like this. Fun? Let's do more. String interpolation switched as well. And so string interpolation is when you do the slash parentheses to print something out. And suppose I have a dog, because for some reason I'm obsessed with dog examples today. You can now provide an extension. Now the extension is to string, but you're specifying it in the case that it's a dog, and you're saying, well, what do I want to do in case it's a dog? And so maybe if you escape a dog, I'll print the dog's name and the dog's age, and so now when you print dog like this, you get Annabelle is 84 years old, and so you can make your strings much more expressive. Keypaths. How many of you use Keypaths? 2? You'll use them more in the future. They're becoming bigger and bigger. And so in this case, I have 2 phrases, and suppose we're testing whether something is a palindrome, that it reads the same from front to back. And so I might take this string, and the way you find out if it's a palindrome is you make everything lowercase, you get rid of the punctuation, you push everything together, you normalize it. And so we might normalize it by taking our string and filtering out all the white space and filtering out all the punctuation. Doesn't that $0 look horrible? Yes, Daniel, it does. And then you lowercase it. This $0, we know what it means. Take whatever's coming in and get rid of it if it's not white space, or keep it if it's not white space. But if we use keypaths instead, it's this. And so instead of the $0, this is now part of Swift. We can use keypath expressions inside of functions. And it just makes it, to me, look more readable, more friendly, using these keypaths inside. Now, don't get excited. It didn't make it in yet. It was there. It got implemented, but they didn't pull it into the main branch. And so it's coming soon. It has been approved. It has been implemented, but it's not there yet. Is anyone using Combine yet? If you're using Combine a little bit, you'll notice that you can do this in the Combine map and filter there. They've implemented it there. It's just not in the regular map and such. Okay. How do I make this work? How would I code this up since it's not in there yet? So if I have a sequence, I can sort it based on all sorts of factors. And so instead of $0 and $1, if I wanted to do it just by Keypaths, I would have something that is generic in an attribute, and the attribute has to be comparable because I got to be able to tell which one comes first. And now this is horrible looking, but we write this once and then we use it in code that looks nice, and that's sort of the key to what we do. We're going to compare it, we're going to sort it by keypath, and so you're going to say, well, what keypath? And you're going to just pass that in, and you're going to tell me what it means to be increasing, and I'll get back an array. And so we'll sort, we have two elements, and we'll ask, are we doing it in increasing or decreasing order? If we're doing it in increasing order, then we'll look at the first element by its keypath, and what keypath lets you do inside is you treat things as if they're dictionary elements. And so that's why we're doing first, and we're accessing the keypath that we're being given. And so we're comparing things. And otherwise, we'll do it in decreasing order. And it allows us to do these things like filter by white space, sort by increasing. How many of you use the result type? How many of you wrote your own result type before Swift 5? So we all did, right? And so a result type is kind of like an optional on steroids. And so if you have an optional either has a value or it doesn't. And so it either works or it doesn't work. And we don't know why if it doesn't work. If it works, we wrap the successful value in and we pass that on. If it doesn't work, we just return nil. And what result says is, well, if it doesn't work, we're going to tell you why. And so result has two cases. It's an enum-like optional. It is generic in success-like optional. So optional is generic and wrapped, but it's that successful value. So if it's a success, we'll return that. And if it's a failure, we'll return the failure and tell you why. So if it's a success, we say .success and we tell you what the value is. And if it's a failure, we don't return nil anymore. We return .failure and we tell you what the failure is. And in this case, failure has to conform to error. And that's why it took so long for them to implement it, because they needed things like error has to conform to error. And so failure conforms to error, and so we return these tuples. If you know other languages, if you know languages like Haskell, this is like an either type. And so you see these types in functional languages. It's that thing where Swift isn't a functional language, but it pretends it can be, and so it can do in a lot of functional things. So here's a function called doubled. I'm going to return a result type, and if it's successful, I'll just double the number and return that int. And if it's not successful, I'll tell you why. I'll give you my input out of bounds error, and in this case, my input out of bounds error conforms to error, or I couldn't use it in result type. And it either is, well, you gave me a negative number, I can't double that, or you gave me a number that's too big, and I'll tell you how much too big it was. So this contrived example, I'm only going to be able to double things that are, say, less than 10. And so I have this doubled, and I check, and I say, well, you've got to be at least 0. If you're not at least 0, I'm going to return the result that's a failure, and the failure is you are a negative number. Look at that information you get. You could do all sorts of switching and understanding based on that. If you're less than or equal to 10, well, I'm pretty happy, but if you're not less than or equal to 10, I'm going to have to report a failure. So if you're less than or equal to 10, I'll report a success. And if you're greater than 10, I've got a failure, and I'll tell you how much you're over. And so if you're in the good range, it's a success, and I'll return the actual doubled value. Now, you know how sometimes optionals are a pain because you have to reach inside and get the thing. You have to unwrap it somehow. It's the same pain here. When I doubled 2, I don't get 4, I get successive 4. So I'm going to have to reach inside. And so I can't do things like doubled takes an int. I can't do doubled, because the first doubled returns a success. You say, aha, Daniel, how do we deal with this? That's why we have map. And the map that we have here is similar to the map we have for array. It's similar to the map that we have for optional. And so the result type comes with a map. The map says you're a function from int to something. That something is our new success. And so I'll be generic in that new success. You'll have to tell me what the rule is for transforming what's inside. How do I transform my int to that new success? Well, I'm going to return a result of that new success, and I'm going to keep the same failure type. So there's only two cases. If you're giving me a result, you're either giving me a failure or you're giving me a success. If you give me a failure, I return a failure. And whatever failed before, I just pass along that message. So this is a lot like optional chaining. And if you gave me a success, I reach inside and I get doubled 2 with success of 4. So I reach inside and I grab that 4, I double 4, and then I rewrap it. Now it's success of 8. And so doubled 2 doesn't make any sense, but I can take doubled 2 and I can map it using doubled again, and that gives me success. And so result type allows us to do things like take a URL from a string. Well, that could fail. Go ahead and hit that URL and see what we get back. I hope I get data back. That could fail. If I get data back, turn it into JSON. That could fail. Well, if I do each one of these in a result, then I can pipe through nicely in my first failure, just like optional chaining. My first failure is a failure, and my successes, I use these maps to just keep going. So you might have noticed that Google's kind of interested in dynamic languages. And the father of Swift is at Google. So now Swift is interested in dynamic languages. So getting things that we can call into Python nicely becomes important in so many ways. And that benefits us when it comes to machine learning and augmented reality, because a lot of the basic work is done in scripting languages, at least till we bring it over to Swift. And so here is a struct called days. It contains an array with Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And so I create an instance of days. And now in my extension, I can look at a subscript. And I don't know that you're taking full advantage of subscripts, because as part of this work, they've added some stuff to subscripts that's kind of nice. Now, subscripts, we mainly think of like get at that index. And so if you tell me days 2, then I'll get the third element of that array. If my subscript says reach inside and return the values at that index. So days 1 is Tuesday. But you can have other parameters in your subscript. So I don't know if you guys are doing this, but this is kind of clever. Your first parameter is still the index, but you can say, I have other parameters that I pass in. And so maybe is reversed is one of them. And so when I reach in there, if I'm in the regular order, I'll return values index. If I'm reversed, I'll count from the other direction. So days 1, where reversed is false, is Tuesday, still going in regular order. But if it's true, it's Saturday. And this second parameter in subscripts is really powerful. Something you're going to like. Along with a lot of these came 195, which was dynamic member lookup. And so you tag it with @dynamic member lookup. You're seeing a lot of ats and $signs and things come into Swift, and makes it a little funny. So here's my dog. My dog has properties that are some dictionary. They're key value pairs, where the key is a string and the value is something that can be displayed as a string. And so I can describe my subscript in here. My subscript says, you specify the dynamic member and I'll output the string if it exists. You might ask me for something that isn't actually a member. And so I'll take my properties, I'll look up to see, do I have a member by that name? And if I do, I will output it. So if I create an instance of my dog, Annabelle, now the dog takes these key value pairs. So Annabelle is a dog where the properties are her age is 12, her name is Annabelle. And so if I ask Annabelle's age, dynamic member lookup works great. If I ask for her name, it works great. If I ask if she's vaccinated, that's not one of the properties. It returns an optional, it returns nil. But this turns talking to these Swift classes, to these Swift types, to be done a lot like we talk to Python objects. And so it makes it easy for us to work across languages. So that's dynamic member lookup. In Swift 5.1, we got the pair to that, which is dynamic callable. Dynamic callable is, if I start with a silly example, I have this dynamic call method that takes arguments. My arguments in this case are elements of an array. So I have an array, and it returns an int. And in this case, I'm just going to tell you how many elements there are. So in my example, if I create an instance of silly example, and I say, give me example 1, 2, 3, it just gives me the count of how many elements that are, 3. It's not a useful example, it's a silly example. If I create example with 1 and a string A, it tells me there's 2 elements. So it doesn't even have to be a homogeneous collection. It can be any type. Now, a more useful example of this is instead of using an array there, what if I give you arguments that are these key value pairs, and I return to you a dictionary, key value types, strings. So here's how I implement it. I create this empty dictionary, and now I fill it. For every argument you pass in, I add this to the dictionary. I say result with the key name is the description. And so now in my example, if I have my example where the name is Annabelle and the age is 12, what you get out is this. Now, remember, order of a dictionary is not guaranteed, so it's not necessarily going to be in the same order, but this is pretty powerful. This isn't something we could do in Swift before, and it helps us interact with any scripting languages in a much friendlier way. Okay. What happened this year? What was the big release? We got 2 big releases. We got SwiftUI, we got Combine, and Apple, right before we saw them, announced all these Swift evolution projects that we didn't see why. And they said, oh, reasons. You're going to love these. And one of these was the opaque result type. The opaque result type is kind of interesting. It's used all over SwiftUI. How many of you are playing with SwiftUI? Great. You guys need to be more adventurous. And so in SwiftUI, we have something that returns some view. And you say, well, what view? I don't know, some view. In this case, it's returning a text. The opaque part is the word some. And you say, well, what I'd really like to do is just say body returns something that conforms to view. I'd like to do it like this. You cannot just say it returns a protocol. What you're saying is it returns something that conforms to the protocol, and what you're telling the compiler is, at compile time, you'll know what I'm returning. You don't have to guess. So in this case, it's text. You know how big a text is. You know how to store it. I could return image. You know how big an image is. You know how to store it. What you can't do is say sometimes it's a text, sometimes it's an image. So if I have this go-to image and I want to display it, what I can't do is I can't say, if that image exists, display the image, otherwise display the text, because the compiler says, well, what are you giving me back? A text or an image? I need to know at compile time. And because this depends on something that isn't known till runtime, this crashes. And so some view says, I need to be able to determine what you're returning to me. You can't sometimes return an image and sometimes return a text. I just can't handle that. In this case, because it's if and else, we saw before, we also need returns in there, but that's not the issue. The issue is that even with the returns, it needs to know what it is. And the error you get from SwiftUI, and I show you this one because it's actually one that makes sense. Those of you that came from Objective-C to Swift, remember in the early days of Swift, the errors were just horrible. It would say, I expect this function to return a string, but it returns a string. You go, I don't know what that means. So it's the same in SwiftUI. The errors are a little puzzling right now, but they're getting better. And so this says, look, you declared an opaque return type, but the return statements don't have matching. One's a text, one's an image. They don't match, so I can't deal with this. And so that's a powerful one. Okay. Function builders. Function builders allow us to say, look, I want to show the image and the text at the same time. Now, I can't do this because body has to return a single thing. It can't return an image and text. So we put the image and the text inside of a vertical stack. And now I'm returning one thing, a vertical stack that contains other things. And this is fine. It's a vertical stack that contains an image and text. And so I get this lovely image above this lovely text. This depends on something called function builders. Now, if you've been watching, I've been including the number of the proposal along the way. And this just says XXX because it didn't make it in. What happened was, after the keynote this year, Apple said, oh, by the way, here's the function builders proposal, and the community freaked out. And the community said, we're supposed to be open source. You were supposed to tell us about this. Now you've just put it into SwiftUI. So it went back and forth, and Apple is being very good open source citizens. It turned out the objections weren't to things that SwiftUI needs, it's the things that might help us with general DSLs, and that's what function builders are for. And so it is implemented inside of SwiftUI now. It is being used now. It is shipping now, but it is not finalized. It has not been through evolution. It might change a little bit. Function builders could change an awful lot. And so the idea of function builders, and I'll show you some real code later, is I could, like we do in UIKit, say, I'm creating a VStack from an image and text. And so this isn't how it really works inside. This is just the idea. Or you could create a VStack, and you could do v.add the way we do with a lot of things in UIKit. We could add our image. We could add our text. Again, this isn't how it works in this case. It's just the idea, but it allows us to write code like this. And it's this pretty code that's nice. Now, VStack, if you look it up, this is the init, and VStack takes an alignment with a default, spacing with a default, and the last thing it takes is a function. And so we've just moved that function out back using trailing closures. So this is just using things from Swift. And so trailing closures is that thing that allows us to take the last closure, if it's the last parameter, and move it outside the parentheses inside of curly braces. And all of a sudden, our code is looking much nicer, and we can decorate it, make it resizable, and add padding, and that looks much nicer than this create from where everything's sort of inside these nested parentheses. And so this is how it looks with function builders. So I want to show you a fun example. This goes back to the 1980s, Peter Henderson, and he declared this whole picture language. And so he said, if you have the letter F, imagine you had something that could rotate F. Just puts it on its back. And if you have F, you could rotate it the other way, maybe unrotate it, or inverse rotate it, or rotate it 3 times. So he had this notion of rotating things. He then said, well, what if we flip things? And he built this whole language around flipping and vertical and putting things together. And the idea was you start with a shape and you define these fundamental transformations. Well, if you look at SwiftUI, we start with like image and text and button, these very fundamental things, and we build up these complex things using these transformations, these containers like VStack and H stacks and Z stacks and lists. And so if you got an F and you can flip it or rotate it or put one above the other or one beside the other, and so it's this idea of sort of higher order functions. And so higher order functions is if I can do above and beside, then I can make a quartet like this. And the code looks like this. This is compiling, running Swift code. In SwiftUI, you can write this, where you say, well, I have something above something else. And the top thing is something beside something else. And the bottom thing is something beside something else. And I compose those, and I get something nice like this. Isn't that the coolest? Really? Nothing? You guys are tough. And so you can feed this quartet in and decide that you want it to look a little different. You don't want the same F everywhere. You want to flip it maybe, and you get something like this. Or you're going to define something else that is cycle based on a quartet, and your cycle might look like this. And once you have these building blocks, you use them to build on each other, and you get this. Oh, come on. You guys clap for a Bach cantata. It's just an iteration. So let me show you the code, and it's going to this part's going to change. How using it isn't going to change. Function builders, if I want something called a rotate, then I also have to create a rotate builder. So here's what rotate builder looks like. Rotate builder contains a function where you specify how many degrees I'm rotating it by and what is it that I'm rotating. And it's going to return you the thing that has been rotated. And there's some details. The name of this function is build block, and you'll have a bunch of build blocks. So this is the rotate builder. You now have rotate that uses the rotate builder. Rotate is the guy you care about. Rotate is the thing that we created, like above and beside. So rotate is something that knows how to rotate content, and in the init, you pass it what the angle is you want to rotate by, and I'll give you a default value of 90 degrees. And it takes a rotate builder, which is a function. It's a function, so you could move it in the curly braces outside. That was the key that allowed us to write that so nicely. And so the rotate uses the rotate builder. This code looks hideous, but it allows us to use it in beautiful ways. And we just say, okay, let my view be this builder. And so when we use it like this. We say rotate, the angle is 60, that's the thing I'm rotating. Or if I assume the angle is 90, I just say rotate, and I pass in the thing to be rotated. Don't you want to write code like that? You can read it. Okay. Keep the code you're writing now. So I wanted to show you this with fish. And so you can do this where instead of an F, you have your Escher fish. And if you rotate your Escher fish twice, you get this. And I don't know if you saw it as it was animating, but they fit together, which was the key of the Escher print. And so if we have a new primitive over, we can say, take your fish and show it over the rotated fish. So we have over, fish, rotate, rotate fish, and they fit together. You go, well, that's pretty cool, but Escher did more. Escher said, what if I rotate 45 degrees and shrink it? They fit together nicely. And I rotate that one again, and they fit together nicely. And all you need for that is one more primitive. So there's these building blocks. You write the minimal code, and then you use it, you compose. Did you guys see, I mean, everybody's seen it, the protocol-oriented programming talk from 4 or 5 years ago that was called the Krusty Talk? Go back and watch it. It's from WWDC 2014, 2015. The first half of the talk is Dave Abraham talking about doing things with protocols and structs that we used to do with classes. If you go back and look at it now, you can see that he was telling us about SwiftUI. This is what became SwiftUI. And this is very common with Apple. Apple's always giving us these hints without telling us what's coming. They're telling us, stop use pixels, start using points. And then in the fall, we get this screen with twice the pixels in both directions. And we go, oh, good thing we switched. Otherwise, we'd have a tiny picture up in the corner. So they give us these hints. He gave us a massive hint. We just didn't know it until we saw SwiftUI. And so this primitive, rotate 45 degrees and shrink, and we just iterate again, and you can build up these very complex things. If you look at SwiftUI, you're using very basic pieces, and you're putting them together in interesting ways. It's very different than working with UIKit. So just as an aside, Escher's fish itself is the same thing. It's the same piece, rotated, rotated and shrunk, rotated and shrunk, and that's why it all fits together so nicely. And of course, so I have a demo. Thank you. What is stunning about that demo, not my design skills, what is stunning about that demo is in SwiftUI, when you move the slider, the numbers in the text field don't change. In that demo, when you move the slider, when the value changes, you throw out the text field and you create a new text field with the new number. You go, that's so wasteful. Well, you thought that when you came to Swift and you heard that arrays were value types, right? So when you modified an array, you weren't modifying the array, you were throwing it out and replacing it with the array that had been modified. And the same thing is going on here, and it is amazingly performant. And Apple can make some predictions and some optimizations based on the fact that these are just structs. And so you're creating, as you move the slider, whatever your tolerance is, every time you move that amount, you're throwing out the old one and replacing it with a new one with a new number. And this is how SwiftUI works. So here is the code for this. I have a content view. It is a VStack. So my VStack is what contains them. I've set them aligning in the center, but I get that for free anyway. I'm displaying text in a slider. That's what you saw in that picture, text and a slider. And so my slider is going to go between 0 and 10, and it's going to change a ridiculous amount of times. Now, I've left the value because this is what works differently in SwiftUI. You guys are so used to, in UIKit, when you press a button, you tell the label, hey, change your value to this. In SwiftUI, everything works with properties. And it says, property change to this. And the text says, well, I'm watching that property, so when it changes, I need to be swapped out. And so we keep that inside something called a state. And the reason we keep it in something with this at state in front of it is, if you remember your Swift, I have a value here, which is a double, which is a value type. I'm inside of a struct. If I change that value, I'm changing the whole struct. That's the way structs work. Structs are value types, so if you change this value, you're changing the whole struct. I can't throw out this view that you're looking at. So what Apple does is this incredible cheat. And they say, we're going to use state. And what state says is, don't store it here inside of my struct. Store it somewhere else. Where, Daniel? Somewhere else. And create a reference to that somewhere else. So now, what I'm holding on to is a reference. A reference is just a pointer in memory. The reference isn't changing. What's in that memory location is changing. And so that's how we can get away with this cheat. The slider is now going to affect the change because that dollar value says I am bound to that value. I'm going to, as I slide, change the value to whatever my slider's position is. The state is going to say, okay, I've been updated. You say, but where? Somewhere. But my reference is to you being updated, and somehow Swift gets the message, this has been updated. You need to refresh with your new text containing the new value. So that's this struct containing a var, and our hack, and it's a big old hack, is state. Now, there was a great talk this year at WWDC. There were a ton of really good talks, but there's one this year by Ben Cohen and Doug Greger about APIs and Swift and some of the new things, and they talked about this, the semantics versus the syntax of value types, and they talked about these things that are called property wrappers. So what's going on here with at state is these are property wrappers where I have my value, but I'm exposing it somehow through a wrapped value. And I'll show you the code here. I have something called to places, and it's a property wrapper. And I've got this struct to two places, and inside it, this is the double. This is the value that I'm really caring about. But I'm going to expose it out in such a way that it is rounded to two places. And so I'm going to have this wrapped value that if you ask me what the wrapped value is, I just return the value. And if you set the value, that's where I round it to two places. So you say, give me a new value that is 1.2345. I'm going to round it to two places. And I do that in the init where I say, look, take your initial value and set it to the wrap value. The wrap value goes ahead and has a setter that sets the value. So if you say set to 2 places the amount 1.23456, this at 2 places to 2 places property wrapper says, oh, I'm doing it through the getter and setter. I'm accessing it through the getter and setter, and so I get 1.23. That's pretty cool. But check this out. This is even cooler. After I wrote this example, and this hipster said, actually, you can do more. And so I looked at this example and said, then let's do more. And so here's my struct to 2 places. What if I want to let you say, I don't want to always round it to 2 places. I want to tell you how many places to round to. So let's create a new property wrapper called rounded to. And rounded to still has my value, but it now has precision. You get to tell me to how many places you want to round it to. And I'll figure out what the multiplier is, 100, 1,000, depending on how many places. So that's not something that we need to worry about. The same getter, the same setter as before, except it's to this new multiplier. And my init looks a little different because you have to specify your initial value and what your precision is. Now, people that use our apps are horrible people. But people that use our code are no better. And so someone's going to try to put a negative number in for the precision, rounded to -4 places. So we're going to guard against them, and we're going to crash because they deserve that. But if they give us a positive number that's reasonable, we'll set our precision, and we'll set our wrap value as we did before. And so instead of using it like this to 2 places, we get to say this. Isn't this incredible? We can just say round it to 3. That's what we're decorating 1.23456 with. And now we can just round this amount to 3 places, and we get 1.235. I think that's pretty slick. So there's a ton of new things in Swift. A lot of them are based on SwiftUI and around there. Also Combine. If you've got questions, now's a great time for them. Thank you.